Hello everyone, this is Hating Tian. In this video, we are learning chapter 7.2, the ambiguous case of law of sign. For the ambiguous case, we say this is the SSA case because the given information is one side. Maybe the length of the first side is S sub 1 and another side S sub 2 and the angle next to the second side. This is 8. So the given information is S sub 1, S sub 2, and the angle 8. Why I'm saying, I will explain later. So first, I could have only one case, one solution. I can use the given information, find the missing information, find the other two angles, and find another side. I say the side is S sub 3. Maybe I have only one solution for finding the triangle. Maybe I have two solutions. So two solutions is here. For example, given information is side A, side B, and angle A. But you see that this angle, so this angle, and the side here is unknown. That means if I could move my A to here, I move my A here. So I construct a new triangle because this angle, and the length here is unknown. So I can move my side here, move my side A to here. I construct a new triangle. That means I could have an obtuse triangle like this. I could also have an acute triangle like this. So I could have two cases, two solutions. And I could have another solution. We say no solution. So the given information is one side. This is S sub 1. And I have another side, S sub 2. And also I know the angle here, the angle A. I got three given information. But the first side is too short. This one has no intercept with the side here. This S sub 3. S sub 3 is unknown. So I have no intercept. Even I rotate my my S sub 1 here, here, or here, but this is the given length. I cannot extend it to have any intercept to the another side. So I cannot construct a triangle. So this one, I have no solution or no such triangle. So I have three cases. First case, I have one solution. Second case, I have two solutions. And another case, I have no solutions. Let's see how to decide how many solutions do I have. Number of triangles satisfying the ambiguous case, SSA. Let's side A and B and angle A are given in the triangle ABC. So if I have the A, I have the B, I have the angle A, I can find a sine B. I can also find the angle B because A over sine A is given and B over sine B. So B is not given. I can solve for the sine B and then use the inverse function, find the angle B. For the first case, if I'm using the law of sine, and then I find my sine B is greater than 1, then there is no triangle. So I know that if I have the any kind of angles sine function, it must be bounced between -1 and +1. If I have the sine B greater than 1, that means is not in the range of the sine B. So there's no solution. Second case, if the sine B equals 1, then one triangle satisfies the given condition. So by solving this, and I solved that sine B equals 90 degree. If I have 90 degree, what is the, oh, sorry, sine. So sine B equals 1 by solving this. And what is the angle of B? So sine B equals y over r. R is 1, so y is 1. So I'm having a point here represent sine B equals 1. Then this angle B is the right triangle, which is 90 degree. I can solve that. B equals 90 degree. And for the 90, we have only one solution. And another case, number 3. In the number 3, we could have one solution. We could have two solutions. If the sine B is between 0 and 1 by solving it, for example, my sine B is 1/2. So maybe I have one solution, maybe I have two solutions. For the one solution, let's see, if sine B equals K, this is not deciding, A is not one solution, is let you know that how to decide we have one or two solutions. The step I need to do first is if the sine B equals K, let the B sub 1 equals the inverse of sine K. Use the B1 for B in the first triangle. Okay, let's solve the first triangle. For example, by solving the equation, my sine B is 1/2. And then by using the inverse of triangle, inverse of sine 1/2 equals B. So I can use my calculator to find the solution. So my calculator for finding this, it only provides us the angle in the first quadrant and the fourth quadrant. If the angle here is positive, it provides us the angle in the first quadrant. The angle, for example, my calculator gives me this 30 degree. So they only provide us the angle here, which is 30 degree. So the B equals 30. But let me ask you, the calculator give me the angle in the second quadrant, but the sine beta is positive. My angle must be in the first and the second quadrant. By the calculator, I find the angle in first quadrant, and the second quadrant angle here, the reference angle is 30. Then this angle is 180 minus 30. So B sub 1, B sub 2. B also could be 150 degree. So by the calculator, I can find one solution. And then by the knowledge we have learned in the second quadrant, I could find another angle. Can I choose the B to have two solutions? It depends. Number B. So use the second solution I have found. That second solution must be an obtuse angle because it's in second quadrant. So if, the angle B, I use 180 minus angle 1. If the A, the given angle, plus the B sub 2 plus this angle is less than 180, for example, the given information, let's say angle A equals 50 degree. And then A plus this angle is greater than 180. That's 200 degree. I know that the sum of three angles cannot be greater than 180. So this is not my solution. But if A plus B sub 2 is less than 180, for example, my A is 20 degree. So A plus B is less than 180. Then the second triangle exists. In this case, use the B sub 2 for the B in the second triangle. Okay, let's explain more detailedly in the example. Okay, let's see. This. All right, let's see the first case. No triangle possible. So solve the triangle ABC if the C equals 39 degree. Angle, the length of A equals 15 centimeter and C equals 6 centimeter, round to 1 decimal place. Okay, so here give us the graph. If the graph is not given, you can graph it yourself. Okay, by the given information, I have the A, I have the C, I also have the angle C. I can list the equation. A over sine A equals C over sine C. And put the given information in it. So the A is 15. The sine A is not given. C equals 6. Sine C is sine 39 degree. So I can find my sine A. So how to find sine A? Maybe I can flip the top and bottom both sides. I'm having sine A over sine B. Sine A equals sine A over 15 equals sine 39 degree over 6, and both sides we multiply by 15. It's 15 canceled. Sine A equals 15 times sine 39 degree over 6. So let's use our calculator to find this. So that's clear. So what do we have? 15 times sine. Oh, I have really bad memory. Sine 39 over 6. 39 divided by sine 36. Is that correct? No. Oh, how I get a really bad memory. Divide by 6. So I'm having 1.5733. So I'm having 1.5733. This value is greater than 1. That means I do not have such angle A satisfied this condition. So there is no triangle. Okay, let's see the second example. Possibility of either one or two solutions. Like make more space here. So solve the triangle ABC if the A equals 57 degree, A equals 62 centimeter, and B equals 50 centimeter. So it gave us B and angle A. This is SSA case. Do we have one solution or two solutions? Let's find the missing information, angle B first, because I know the A over sine A, they are given. And I also know the length B. Let's find the sine B. So 62 over sine 57 degrees equals 50 over sine B. Sine B is not given. So if I want to rescue the sine B, flip the both sides, make it to the top. So sine 57 degrees over 62 equals sine B over 50, and then multiply by 50 both sides. Sine B is isolated. I have 50 times sine 57 over 62. And then I can use my inverse function to find the angle B. So angle B is inverse of sine 50 times sine 57 degree over 62, and use our calculator to do the computation. So we have on the top, we have second sine, this is the inverse. On the top, we have 50 times sine 57, close the parentheses, all divided by 62, and close the parentheses. So it's about 62.5588. If I want to keep one decimal place, I'm having 42.6. 42.6. So at the beginning, I mentioned that if I use my calculator to find the angle B, it only provides us the value in the first quadrant, 42.6. I also need to have another angle in the second quadrant because I have the sine B maybe is greater than sorry, sine B is greater than 0 is a positive angle. I didn't do the computation. You can also test that if sine B is positive. So if I'm having sine, what is the B's value? Is the 50. So 50 times, okay. So that's 50 times sine 57, all divided by 62. What is that? Oh, it's 0.6763. So I skip the steps. You can do this first. 0.6763. So this is the value of the sine B. So it's less than 1. And that means we must have the solution. And then you bring this one to the inverse function. You'll find this angle. And we need to know that we also have another angle, maybe another angle in the second quadrant. And the reference angle is 42.6 degree. So this is B sub 1. And also I have B sub 2. I use 180 minus 42.6 degree. And this one is about 137.4 degree. And then we continue to find if I could have two solutions. So I must have my first solution because this is acute angle. But the second one is obtuse angle. Can I choose the second one? I don't know. I need to test. If my B sub 2 plus the given information, which is A, is less than 180, yes, I have two solutions. If it's not, we have only one solution. So it's 137.4 degree plus A is 57. I feel this angle is too much. So this angle is 194.44 degree. It's greater than 180. No, the two angles, the sum of two angles in the triangle is greater than 180. I cannot construct this kind of angle. So there is no such angle, obtuse angle that satisfies this condition. So this is a false statement. I have only one angle, which is the B equals 42.6. So B equals 42.6. How to find the angle C? I know the angle A. I know the angle B. So use 180 minus A minus B. This is 180 minus 57 degree minus 42.6 degree. So the angle C is 80.4 degree. So if I have this, what is another missing information? The side C. So I can use A over sine A because A and angle A, they are given, equals C over sine C. Only missing information is C. So both sides multiply by sine C. A times sine C, all divided by sine A. Then the C equals, the length C equals, A is 62. And sine C is sine 80.4 degree. And the sine A is sine 57 degree. And let's use our calculator to do the computation. We have 62 times sine 80.4, all divided by sine 57, close the parentheses. Hit enter. That's 72.89125 something. So I keep one decimal place. I have 72.9. So solution of the C is 72.9. And what is the unit? Centimeter. So I found all the solutions. I have the A equals 57 degree, B equals, what is B? B is 42.6 degree. C is 80.4 degree. And A equals 62 centimeter, B equals 50 centimeter, and C equals 72.9 centimeter. Okay, you will see this case we have only one solution, because when I'm adding the second of the obtuse angle of the B, this angle or the second angle of B, and A, the given information A, I see is greater than 180, so I do not have my second solution. I have only one solution. Let's see next case. You see I leave a lot of space here. That means I may have two triangles for this example. Example 3, solve the triangle if the A equals 29 degree, lowercase b equals 10 inches, and A equals 7 inches. Find the triangles. Solve for the triangle, round to 1 decimal places. There's no image for me, there's no picture, so maybe I can graph it myself. So I have one side with the A equals 7, angle A and B. So I say this is A equals 7, and another side is B. Another side B is 10. And the opposite of the A is A, angle A. So I say this one. I know this angle is 29 degree. So I feel this one is too long. Okay, so maybe I could have another case. I don't know. I just, maybe later I need to try. Maybe A is here is equals 7. So let's see, do I have two cases? Let's solve it. By the given information, A over sine A equals B over sine B. Can you solve for the B? Yes, we flip of the both sides first. We have the sine A over A equals sine B over B, and rescue the B, or rescue the sine B. Isolate the sine B, both sides we multiply by B. Sine B equals B times sine A over A. So let's use our calculator. The B equals 10 times sine A, sine 29 degree, all divided by 7. We can use our calculator, and later we can find the angle B by using the inverse function of this value. I don't know, is equal to or approximately equal. So that's, we have 10 multiplied by sine 29, close the parentheses, divided by 7. So it's about 0.692585. So let's see, 0.6926. So how about the inverse function? Inverse function, I can use the calculator. So I click second, sine, and then put this value inside of my sine, close the parentheses. It's about 43.835 degree. So round to 1 decimal place, I'm having 43.8. So I bring this one here, 0.6926. The angle B is about 43 point what? 0.8 degree. And this is the angle I found from the first quadrant. My calculator gave me this angle. So find the angle in the second quadrant here. So use 180 minus 43.8. So this is B sub 1, maybe B sub 2 equals 180 minus 43.8 degree. And do the computation, I'm having 136.2 degree. And then we need to test if my obtuse angle B, this angle, plus the angle A could make a angle less than 180. So let's test. Angle A plus B sub 2 is 29 degree plus 136.2 degree. What is this? So by the computation, I'm having 0.2 degree. I'm having 165 degree. 165.2 degree. So it's less than 180 degree. So that means I can find the C's value. If it's too much, I have no such a C value satisfied. The sum of three angle equals 180. So yes, I can keep both conditions. So for the angle, so first solution, the B sub 1 equals 43.8 degree. And for the second case, the B sub 2 equals 136.2 degree. I have two solutions for the triangle. And then finding the two triangles, first I need to find the angle C. Angle C equals 180 degrees minus A minus B sub 1. This is 180 minus 29 minus 43.8 degree. Yes, and the solution should be, okay, so you can use your calculator. And then I got 107.2 degree. You can also use your calculator to prove that. 180 minus 29 and then minus 43 point, no, 42.3. Yes, 43.8. Yes, is the 107.2. 107.2. So another missing information is the side C. I can use A over sine A equals C over sine C. Solving for the C, so I'm looking for the lowercase c, and this one is the uppercase c, that's the angle. So finding the c equals A times sine C over sine A. Use a calculator, I can find that A, put all the information in it. A is 7 times sine C. Sine C is, we found that is 107.2 degree. All divided by sine A. The angle is 29 degree. So let's use our calculator to approximate the solution. So we have 7 times sine 107.2, close parentheses, all divided by sine 29. So we have 13.7929. We need to keep one decimal place. We have 13.8. So the solution of the C is 13.8. The unit is inches. So from the first one, I got all the information. I can list say that triangle ABC. The case one, I can say A equals 29 degree, B equals 43.8 degree, and the angle C equals 107.2 degree. And for the side, A equals 7, B equals 10. They are all inches. And the C is 13.8 inches. All right, let's see the second case. So I have the B sub 2. I can find the angle C. Angle C is 180 minus A minus B sub 2 is 180 minus 29 degree minus 136.2 degree. And by the computation, my C equals, do the subtraction, I have 14.8 degree. And then find the side C. A over sine A equals C over sine C. So isolate the C. C equals A times sine C over sine A. So C equals A is 7 and sine C, the C is 14.8 degree, all divided by sine A. Sine A is sine 29 degree, and use our calculator to approximate the solution. So I'm having 7 times sine 14.8, all divided by sine 29, close parentheses, is about 3.688. And we need to keep one decimal place. I have 3.7. So the solution is 3.7 inches. I have all of this information. I can list the solution of the second triangle. So A is 29 degree. B, now that's a B sub 2. B is 136.2 degree. And the angle C is 14.8 degree. And the side A is given is 7. And side B is given is 10 inches. And the side C we have found is 3.7 inches. All right, we're done for today. We solved several examples of the SSA case. This one we called ambiguous triangles. That means I may have 3 cases. Let's do the conclusion. What is the first step? If the given information is A, B, and the angle A, I can find the angle B first. So by listing this, the A over sine A over B over sine B, I can find the B. So B equals something. I can use the inverse function 1 to find the B. But for solving the B, I may have one case in the first quadrant. Maybe I have another angle in the second quadrant. If I can decide, I could choose the second quadrant. My triangle is obtuse angle. I need to use this angle plus a given angle A. If I can prove A plus B is less than 180 degree, so I could have 2 cases. So I can keep B1 and B2. And if I cannot prove this is greater than 180 degree, that means we only have 1 case. And there is another one that when I'm solving the sine B is greater than 1. For example, is 2. Greater than 1. There's no solution for this one. All right. These are some examples we have learned today. And let me know if you have any question. Have a good one. See you next video. Bye.